out the aluminum with the oxygen. So I'm going to start off with an Al plus a little O2, and that's going to yield ALO. Do a little thinking about this, and I should get 2 aluminums, give me 3 oxygens. Pausing there. Anybody need that help? Okay. Then I recognize that I've got a problem here, so I put a 2 in oxygen. That doesn't work, so now I've got to put a 3 here and a 2 here, and end up with a 4 out here when I get done pausing. Okay. If I'm in your way too much, just tell me to move. I don't make a good window. You're the one I'm worried about. Right on the edge of not being able to see. Okay? All right, let's move forward. So now I've got to start off. How much aluminum do I start with? I'm going to start with 100 aluminum. 100.0 grams of aluminum. Where? Now I go find my chart. Aluminum is, I should probably be asking somebody a question. Hanson.
1 mole of aluminum is 26.982 grams.
So 1 mole of aluminum is 26.982 grams. Yet another reason to use this chart rather than that chart, because aluminum is taken out to 9 digits over there. Lovely. Not going to change your answer, and a headache to write down. Okay, moving forward.
Oh, 2 AlO3s.
Oh, I can buy that. 2 aluminum oxides.
Is 4 moles of aluminum.
4 moles of aluminum. I love it. Now I'm in aluminum oxide, so I got to figure out the mass of aluminum oxide. Ew. That's 2 times 26.982 plus 3 times 15.999. Two times 26.982. Plus 3 times 15.999. Love it. I'm getting 101.961.
Yeah.
Technically, this is adding, so therefore I get to keep all those digits. Not that it's going to matter. That's going to limit me a long time before this does. So we keep all the digits anyways. So it'd be 1 mole of Al2 aluminum oxide is equal to 101.961 grams. And now I know how much aluminum oxide I can make with that much aluminum. So 100 times 2. 1 divided by 26.982 divided by 4. And I'm getting 188.9 grams.
Yeah.
All right. B. Bodell. Give me my next row.
100.
Have 100 grams of oxygen?
Yeah.
All right. Of oxygen? Where?
15.99.
Each one of these is a molecule because it's got O2 in it.
Oh.
So I'm going to need to double that, don't I?
Yeah.
If I double it, I'm going to get 31.998 grams is 1 mole of O2. Okay?
Yeah.
And it's like this thing, a molecule over here. Okay? For every, how's my ratio? Moles of oxygen and moles of aluminum oxide?
2 to 1.
2.
Oh, 3 to 2.
3 to 2. So if I have 3 O2s, I should be able to make 2 Al2O3s. Agreed? Give me the last stack.
101.961 over 1 mole.
1 mole of the good stuff. It's actually not good stuff. It's like aluminum rust or something. Good?
Yeah.
Okay, so now I'm going to go 100 times 2 times 101.961 divided by 31.998 divided by 3. And the amount of aluminum rust I can make with that much oxygen is 112.4 grams. Mr. Logger,
Yes.
you ready for the next question, or you need a little moment? I'm going to take you another moment. Ready for my questions?
Yeah, I think so.
Okay, here we go. Yo, she got a question. Yes.
Wait, why is it 2 on top? Like 2 times for the ratio. Oh, so it's going to.
Takes
why
2.
Then why is it only 1 on the top?
1 down here.
Wait,
Are we okay? All right. Logger.
Yeah.
First question is, what would be the limiting reaction? What am I going to run out of?
Oxygen.
Okay, so let me back up a second. Reactant. I can do that. Okay, so question. So if I have 100 grams of aluminum, I can make 188.9 grams of aluminum rust. 100 grams of oxygen makes 188.9 grams of aluminum rust. If I have 100 grams of oxygen, I can make 212 grams of aluminum rust. Which one am I going to run out of? The aluminum. Does that make sense?
Yes.
Okay. So aluminum. Should just write an AL if we're too lazy to write all that out. As chemists, we shouldn't have to do that. How many grams of aluminum oxide will be made? How many grams of aluminum oxide am I going to make?
No, 180.
Yep, I'm going to run out of ingredients before I get to the 212. So I can make 188.9 grams of aluminum oxide. Probably next thing is what's left over. How much remaining reactant will be left over? Okay, how much oxygen are you going to have left over?
$11.1 grams.
11.1 grams. It'd still be left in the tank when I ran out of aluminum. Are they getting better? They're getting better. Hanson says yes. Graber. Is it getting better? Yeah, a little bit better, not massively better. All right, flip it over, try the problem in the back. I want to direct your attention to the first little bit of that. It says here, if I burn 10 grams of rubidium is burned with an excess of oxygen, how much rubidium oxide would it make? What does it mean by excess of oxygen? Who do I want? Henderson.
The 12 oxygen that was left when we calculated the amount of...
You overthought it. This is a whole separate record. It's not like the first thing didn't happen. What would I mean by the excess of oxygen?
How much is that?
Oh, the remaining oxygen?
When I say I have an excess of Diet Coke, what does that mean?
Too much.
I have too much. So in other words, I'm not going to run out of oxygen, is what you're telling me. Oxygen is not the limiting reactant. What's therefore going to be my limiting reactant in this case? Rubidium. So this is one situation where I'm just burning the rubidium in this room. I can't run out of oxygen. At least I hope not, because that would be bad for me standing next to it. Right? There's a lot of oxygen in this room. You burn rubidium, you got plenty of oxygen. So how much rubidium oxide can I make? Does that make sense?
Yeah.
So this problem is subtly different than the other one. All right, have at it.
So,
Like, look at, I circled it and X'd it out twice.
All right,
One mole.
here we go. 10 grams of rubidium.
This is what it is. So you have it's
Where?
No, you do. It's 4 rubidium. It's 4 rubidium because 2 times 2 plus. Just
85.47 grams is
So-
1 mole.
So
I
it
had
would
one over
be,
one.
it would be
One over
4
one, and you had
rubidium
2 over
plus
2.
oxygen, which is 3.
Then 4 rubidiums
879.
is 2 rubidium oxides.
So it'd be 10.
And now I got to do rubidium oxide, which is going to be 2 times 85.47. Is that all I get? 47 is all I get? Rubidium's not very carefully measured yet. Okay, and then plus I need to do 1 times 15.999. Two times 85.47 plus 15.999, and I get 186. So 1 rubidium oxide is 186.93939 would be better. So then I multiply that by 2, multiply that by 10, divided by 85.47, divided by 4, and I get the 10.9 grams I didn't believe was the right answer a second ago. Okay, 10.9 grams, I like it. All right, try that last problem, have fun. Go to the bathroom, yes. They can't. Brand's in there. Yeah, get his cell phone update. Never know.